So we're going to look at metamorphic rocks. Go ahead and sign in. Again, I do need a real name. Don't need a PIN number and ID. So I got one more person. Is it you? Okay. Well, you'll catch up. Okay, so we're going to look at the formation of metamorphic rocks. We've already looked at sedimentary. We've already looked at igneous. We're going to now cover metamorphic. Okay. This is again something that would be great if you're taking notes on these things as examples. So, metamorphic rocks form when other rocks are put under lots of heat and lots of pressure. Okay, so they take two things, heat and pressure. Where we take other rocks and put heat and pressure on them. So what this shows is an example. We have molten rock and we have layers of, say, sedimentary rocks. As they get pushed deeper and deeper and deeper, as they get close to this magma that's underground, they get both pressure from the layers on top of them and heat as they get close. And that will change them into another type of rock. They'll change them into metamorphic rocks. Okay? So those are the two things that we need, is heat and pressure. Here's another example. We've got magma rising where this would be igneous rock. And up here it's maybe becoming a volcano or something. And we've got sedimentary rock here where it's under pressure. And as we apply some additional heat to that, that's where we get different types of rocks. Okay, where we can get metamorphic rocks. Okay, so the key thing that makes metamorphic rocks is heat and pressure. So I have a question for you. Which types of rocks can turn into metamorphic rocks? And metamorphic rocks turn into metamorphic rocks, and sedimentary rocks turn into metamorphic rocks, and igneous rocks turn into metamorphic rocks, or can any of them turn into metamorphic rocks?
他之前说的是 metamorphic rock 是其他的岩石经过压力跟温度提升之后呢，变成什么？所以简单的说，是 metamorphic rock 呢，一开始有可能是 igneous， 也有可能是 sedimentary。然后因为它那个被压力一直压，然后越接近地壳那个壳心的时候。
Okay, so I'm going to share this with you. Most of you responded. Any of them can turn into metamorphic rocks. We can even take one type of metamorphic rock, apply more heat and pressure to it, and turn it into a different type of metamorphic rock. Okay? Our two examples showed sedimentary, but we can even take igneous rocks that have cooled. So they have to be cooled. So magma or lava is not an igneous rock yet. It's just magma or lava. Okay, so we can take any of the three types of rocks, add heat and pressure, and turn them into a metamorphic rock. Okay? Alright, so this is a graph that kind of shows how the depths that we have to push rocks to get the pressures that we need and the temperatures that they get. Okay, so what this shows is anything above this line will basically become a sedimentary rock. If it has any of this, if it's about 7 kilometers under the Earth's surface, it becomes a sedimentary rock unless it gets, above 800 degrees, then it will melt, and that will make it become an igneous rock. So all of this section right here is where the rocks have melted, and they will be magma at that point. Okay, so if we get anywhere we have more than this depth, which is pressure, and more than this temperature, then we will turn just into molten rock. It will become magma. Okay? So that's what this whole section here is. What this shows is kind of a transition point. This dotted line is boundary between where sedimentary and metamorphic rocks form. So our metamorphic rocks form basically more than 7 kilometers below the Earth's surface. About 3 miles, okay? A little more than 3 miles, 3 or 4 miles. So anywhere below that depth is where we form metamorphic rocks. Okay, and then anywhere in here can form different types of metamorphic rocks. What this has is one example. We take clay and we deposit it. It'll turn into shale, it's a sedimentary rock. But then as we add more heat and pressure, it becomes slate. And then that metamorphic rock turns into phyllite. And that metamorphic rock phyllite turns into schist. And then schist will turn into gneiss. Okay? So we can see as we add more heat and more pressure, even our metamorphic rocks become different types of metamorphic rocks. Okay, so that's what this graph shows, is as the deeper we go and the hotter the temperatures we get different types of rocks. Any questions? Okay, so if a rock is under too much pressure and high temperatures, it will become a what type of rock? Okay, so if we're talking too much heat and pressure, we're talking about this section here. What happens if we put too much heat and pressure? The rock will actually melt, okay, which would make it become an igneous rock. Okay, so here is where we're making metamorphic, where we have heat and pressure. We wouldn't call that too much because it's going to just make it a metamorphic. Okay, so I would probably reword that question. If a rock is under too much pressure and high temperatures, it may become an igneous rock, okay, rather than a metamorphic. It's going to actually melt if we put too much heat and pressure on it. Okay, so I'll adjust how that question is worded for you. Okay, so we have two main ways that we can make metamorphic rocks. Okay, two ways that we can do that. We have regional metamorphism and we have contact metamorphism. Okay, regional is where we have high pressures and high temperatures across the whole region, a whole bunch of rocks. Okay, that usually happens like underneath mountains. Okay, or at places where we're pushing rocks underneath, or pushing plate tectonics, which is what our next unit is on. We're pushing plate tectonics underneath other plates. Okay, that's where we take a whole plate, a whole area. So we're making metamorphic rocks underneath this entire mountain. Okay, and that is regional metamorphism. We're getting pressure because we're pushing this under, and pressure because it's underneath a lot of rocks, which makes it heat up. We have high temperatures and high pressure. Okay? Then we have contact metamorphism. This is where we have lower pressures and high temperatures. Okay, so what this is, like this says this is an inclusion in granite. This is where we have a hot magma coming up into another rock. Okay, this is where an igneous inclusion is coming in, and we're going to have along this edge where it's in contact with the other rocks, it's going to be heating that up, and it's going to make it metamorphic rocks. Okay, so the difference is this can be lower pressures, it's not as deep underground, and it's because there's magma or something that's getting close by that's making it hotter than it would normally be. Okay, so two types. Regional metamorphism, high pressure, high temperatures over a big area. Contact metamorphism is lower pressures, high temperatures over a much smaller area. Okay, just where it's in contact or right next to very high temperatures from magma. Okay? So your question is, what is contact metamorphism? And what might cause it? What is contact metamorphism and what might cause it?
他问你说，碰触变化有什么可能？什么东西会让它变化？什么东西会让它变化？或者是
Okay, what is contact metamorphism and what might cause it?
所以 碰触变化的话呢，它在什么样的情况下会形成？
低压力、高温度。
低压力。刚说什么东西？
原浆。
Only got about a third of you that have responded. Make sure you're putting down an answer. What is contact metamorphism and how might we cause it? I'm waiting for Dreama, Sydney, Travis, Kenna, and Jules. Jules, I just got yours. Kenna, did you reply? Oh, there it goes. Okay, let's take a look at this one. So we've got lower pressure, high pressure in a small area. I might change this to say lower pressure, high temperatures in a small area. Okay, and we want to know what causes that high temperatures. And so this one says magma rising and melting the rock, and that's very good. All right, we're not as deep, and we've got it where the magma is coming up, and it causes it to be hotter at that point. Okay, let's look and see. Here's one. Contact metamorphisms is when there are low pressure but high temperature, and magma might cause contact metamorphism. Okay, here's one caused by magma, and that's correct. So I'm going to go back one and we can look at that picture again. Okay, again, so contact metamorphism is the one that's on the right, and that's what we're talking about, where this granite, which is an igneous rock, has pushed up into it and it's hot, and it's slowly cooling, and on the edges is where we're getting contact metamorphism. Okay, so it's a lower pressure and a high temperature, and it's in a small area, instead of high pressure, high temperature in a large area. Okay, so we're going to look at some characteristics of metamorphic rocks. One of the there's two major types of metamorphic rocks, and those are regional and contact, but we also have foliated and non-foliated. Okay? Foliated is where we've got these bands or these lines. If you're seeing lines that look like this, where they're squiggled and squished, that's definitely metamorphic rocks. Okay? Sedimentary rocks also have lines, but they're very even, okay? Very flat lines. And we can even take metamorphic rocks, we take sedimentary rocks, and when we squish them, is sometimes where we can get those lines. So what's happened, this is an example of an igneous rock that we've then squished and put under lots of pressure and heat. Okay, where these would be the crystals that we would normally see in something like granite. Remember, if we remember igneous rocks, we had crystals that we could see with our naked eye, and if we squish them, all of those crystals flatten out. Okay? Where somewhere very nearby that you might have seen this? Next time you
那
drive
如果
through
你
the
看到有
canyon,
些石头
I
上
want you to look at the walls as you drive through.
就是说呢，
There are
这
definitely
是
some
一个
sections that look a lot like this, okay, where we've got squished bands of rock, and those are metamorphic rocks, okay? So as you drive through the canyon, look at that closely. Okay, the other option is we have non-foliated, and then you can look really closely at this, and we'll look at some examples in class. You can kind of see that there's little flaky sections of that rock. They're not going to flake off like some sedimentary rocks are, but they look like they are chunks of rock slate that's squished together. Okay, that's again where we're taking those rocks and putting them under lots of heat and pressure. Okay, and you can kind of see those are some tips and clues to identify the general types of metamorphic
它
rocks.
最左边
Okay,
那
so we
个
have
石头
foliated
看起来
and
层
non-foliated.
层要分
Where
开。
foliated is where we've got these bands or these
它
stripes
这
from
一
being
种
under
叫
lots of pressure.
non-foliated，我不知道是什么石。
Okay, so we've talked about igneous rocks and how they're the best ones that we can use to identify the age of the rock. We said that metamorphic are okay, but oftentimes we still have to use that sandwiching that we've talked about to identify metamorphic rocks. Because again, we're taking other types of rocks and we're turning them into another type of rock. Okay? And so that's still a similar issue that we have with sedimentary, is we will use igneous rocks above and below our metamorphic rocks to figure out how old they are. Okay, one thing that makes metamorphic a little better is sometimes if we put too much heat, too much pressure, it turns into igneous, right? And then there's igneous really close by or inside of metamorphic rocks to figure out how old they are. Okay, that's why metamorphic rocks have a little bit better chance of being able to be dated. If we can find an igneous rock that's really close by, because it is under that heat and pressure, we can figure out how old it is. A little better than sedimentary.
所以这个跟之前讲的一样。
Okay, so question is, the best way to determine the age of a metamorphic rock is what?
就是去找 igneous 跟两个混的石，找东西。所以问你最好的方法，找出用什么方法最容易找出这个石头的年龄。
Well, you should be doing it yourself so I can see yours. So when you pull up, really. Join session.
So 所以我说一样，就用三明治的方法来找出那个 metamorphic 上面跟下面的混合石。
你在会加油就看得来。
Okay, so I'm waiting for Josiah, Will, and no, I just got Travis. Okay, so let's take a look. Some of your responses. Best way to determine the age of a metamorphic rock is to use an igneous rock next to it. Very true. Okay. We've got a lot of sandwiching. Okay, sandwiching with what?
Ham and cheese.
Not ham and cheese, but igneous rocks. Okay, so we got a sandwich with igneous rocks. Okay, so I'm going to go back and we're going to look at this again. Okay, so if we said, for example, this was a metamorphic rock, we can't necessarily know exactly how old it is, so Sam, make sure you're paying attention. But if we know how old this rock is because it's igneous and how old this rock is because it's igneous, we know that that metamorphic rock is between those two ages. Okay? That's why we call it a sandwiching. It's like a piece of bread on the bottom and a piece of bread on the top. We know that everything must be between those ages. Okay? So we're going to look at some examples of metamorphic rocks. And we're going to look at rocks before they have heat and pressure and what they become after they have heat and pressure. Okay? So here's an example of we take mudstone, which is a sedimentary rock. We add heat and pressure and we get slate. Okay? The tables that you're sitting on, the bench, the black stone is slate. Okay, so that's a metamorphic rock. Okay? Here's an example. We then can take slate, which is a metamorphic rock, and we can turn it into schist. I know that's a funny word. We really think it's hilarious. But it's just the name of a rock. Okay? So we take slate, and we add more heat and pressure, and it turns into schist. Okay, here's another example of basalt, which is an igneous rock. We add heat and pressure, and it becomes amphibiolite, which is a metamorphic rock. Okay, we can kind of see some similarities. We've got some lines and things here, and then we've still got some of those crystals that are there, but we've added heat and pressure and changed them. Here's another example. If we take another metamorphic rock, schist again, we add more heat and pressure, it can become gneiss. Okay, and we say that nice, not good nice, it's nice. Okay? So here's a question for you. Foliation of metamorphic rock is what? Is it stripes or bands of squished rock? Is it lithified pieces of rocks? Is it large and small crystals?
他问你说 metamorphic rock foliation 是以下哪一种石头？第一个呢是它有一条一条的线，第二个是呢它是很多石头之后粘在一起，然后第三个是它有很大很小的。
Kylie, Maggie, Will, Grima. You guys respond? Will, did you respond? Okay. Alright, so let's look. So most of you, 84% of you said it was stripes or bands of squished rock, and that's correct. That's what foliation is. What type of rocks do we have lithified pieces of rocks? What kind of rock is that? That would be sedimentary, right? Lithification is our last step in making a sedimentary rock. Okay? Nobody said large and small crystals, but what kind of rock would that be? Igneous, right? We would look for large or small crystals. We'd have lithified pieces of rock in sedimentary, and we've got foliation, which is bands or stripes in rocks, squished rocks for metamorphic. Okay, let's look at a few more examples. Okay, these are ones that are non-foliated. They don't have any of those bands or lines. Bituminous coal, which is what kind of rock? Remember? It's sedimentary rock. Okay, so one where we put lots of, we put mostly plant material, put it under layers, and it becomes a rock. Bituminous coal, we add heat and pressure, it becomes anthracite coal. It becomes much shinier. Okay, that's the difference between those two. And one's a sedimentary, one's a metamorphic. Okay, conglomerate. What kind of rock is conglomerate? What do we see in it? No, those aren't crystals. We see chunks of other rocks. So it'd be sedimentary, right? We see different sizes of sedimentary. If we take that type of sedimentary rock and heat and pressure, we get a metaconglomerate. But you can kind of see that those rocks are now flattened and squished, right? So big chunks of rocks have become flattened and squished because of heat and pressure.
所以看像这个是它被高温跟
Okay, let's take a look at limestone. Limestone is what kind of a rock? Right, sedimentary. It's made up of other pieces of rock or other material. We add heat and pressure and it becomes marble. Okay? Marble is one of those rocks that we talked about that's not foliated, but it's kind of got those little flaky looks to it. And you can see that oftentimes in marble stone or marble flooring or something of that type. Okay, so here we have sandstone, which is what type of rock? Sedimentary, and we can see the difference in the layers. Sedimentary rocks layers are nice and even and smooth, whereas metamorphic are sometimes squished up. Okay, and then we have heat pressure and it becomes quartzite. Okay, those are some examples of what a rock might start as and what it might become. I have an open question for you. Is to describe how metamorphic rocks are formed.
对，解释 metamorphic rock 是怎么形成的？怎么形成的？
How do we make metamorphic rocks?
怎么形成的？
它有两种是吧？
所以有两种方法。
一种是那个叫什么呀？它在这个有一种是那个岩浆的那个。
那个叫什么？ OK， 岩浆。我说岩浆的，然后呢，所以一个方法是因为岩浆。
Alright, looks like I'm missing Travis, Yudon, Will, Trey, Shamey,
还有吗？没有也没关系，
Kenna.
现在不记得有关系，
不记得了。
不记得了。有两种，地区性的跟碰触性 ，regional 跟 contact。contact 就是像你说的岩浆，它高温度、低压力。另外一个小区域，另外一个呢 regional 地区性的是高温。
Hey, it looks like I got most everybody. So a lot of people have said the correct answer, which would be by heat and pressure. Okay, so we make metamorphic rocks by heat and pressure, and we can do it in one of two ways. Okay?
它有高温度和高压力。不是，就是温度。
We can do it by either regional or contact metamorphism. Regional is where we have high pressure and high temperatures, like underneath mountains, or we're building up mountains. Deep under the ground, underneath those mountains, would be lots of heat and lots of pressure. Or by contact, which is low pressure and high heat, which is where magma might be coming through. And a batholith or a dike could be coming through and adding that contact metamorphism. Okay? So let's go ahead and stop that. That's going to be the end for